that leads us into a discussion of percentiles. So when we talk about a percentile, we're going to take some number and call it the Cth percentile. So what I mean by that is if you wanted the 50th percentile, or if you wanted the 98th percentile, or the 10th percentile, you can do any numerical percentile. Typically we do use whole numbers between 0 and 100. What that percentile gives you is it provides you the value where that percent of observations lie below it and the rest lie above it. Now you can think of the median as being the 50th percentile because the median is where 50% of the values are below it. The quartiles, the first quartile is where 25% is below it, so that's at the 25th percentile. And then the third quartile, the upper quartile, is where 75% of the observations are below, so that's the 75th percentile. So in any normal distribution, then if you go one standard deviation above the mean, so any distribution, as long as you have a z-score of 1, that's always going to represent the 84th percentile. So since every standard score for a normal distribution translates into a specific percentile, it's going to be the same no matter what the mean and the standard deviation of the original normal distributions are. So that's really valuable. By getting these standard scores, it means that we can take any distribution and get them into the same, the same comparative place. You have a table at the back of the book. It's called Table B. And that Table B is going to provide us with all of the percentiles that correspond with different standard scores. I've attached this table to your notes if you don't have the printed textbook, and it also is typically linked in a homework problem when you need it. So you can see on this table you have all of these different standard scores, and it provides you with the percentile. Now, most of the time when we give percentiles, we do give a whole number percentile, but this table is a little more specific and it will actually give us a decimal percentile for even more accuracy. So let's take Madison and Gabriel. Madison had a standard score of 1. So that means that she was one standard deviation above the mean, and that puts her at the 84.13 percentile. So it's around the 84th percentile, but specifically, she scored higher than 84.13% of test takers. Now, Gabriel had a standard score of 0.5, and so he was there at the 69.15 percentile, which would be about the 69th percentile, and he scored higher than 69.15% of the people in the distribution.